Good afternoon, students. Welcome back once again to the mathematics class. So, in today's lecture, we'll continue solving the examples based on linear differential equation, right? The next example is today's series. Example 1 1 plus x square dy plus 2xy dx, which is equals to cot x dx, where x is not equals to 0, right? This question is given. Let us consider the given solution. Write on the given once again. 1 plus x square dy plus 2xy dx, which is equals to cot x, right, into dx. So now we have to convert it into the standard form, right? So in the dy by dx form, dy by dx plus py, which is equals to q. We know already standard form of a linear differential equation, right? So for this, dy by dx means here we have to convert it or take dx term one side here, or dividing both side by 1 plus x square dx. Let's see what we get. Dividing both side by 1 plus x square dx, right? We have to divide the terms LHS and RHS, both the sides. Let's see what we get. 1 plus x square dy, which is equals to 1 plus x square dx plus of 2xy dx, which is equals to 1 plus x square dx, which is equals to cot x dx upon 1 plus x square dx. So here this term get cancels. The remaining term is, which implies dy by dx, which plus 2xy upon 1 plus x square, which is equals to cot x upon 1 plus of x square, right? So now this is in the linear equation of the form, right? So now we have to compare this equation comparing with the standard form dy by dx plus py, which is equals to q, right? Where value of p is, after comparing value of p, what we get here, 2x upon 1 plus of x square, and value of q is cot x upon 1 plus x square, right? So after getting p and q value, now we have to find integrating factor again, if, which is equals to e to the power of integration p into dx, e to the power of integration, value of p is what here, 2x upon 1 plus x square into dx. So here the integration of 2x upon 1 plus x square is log of 1 plus x square, right? It is the value which is equals to e to the power of log 1 plus x square, log 1 plus x square, right? So here e to the power log get cancel, only what we get here, 1 plus x square is the value of integrating factor here, right? So now substitute in the general form of a given differential equation is given by the relation. That is, we have y equals to the relation y into integrating factor, which is equals to integration of q into integrating factor dx plus of c, right? So now substitute integrating factor y as it is. Integrator factor is here 1 plus x square, right? Now integration of value of q is cot x upon 1 plus of x square into integrator factor is again 1 plus x square, right? Close the bracket into dx plus of c. Here 1 plus x square, 1 plus x square get cancel. Y into 1 plus x square integration of cot x dx plus of c. So y 1 plus x square integration of cot x is what here? Log of sin x, right? Log mod sin x plus of c. Hence, which is nothing but our required solution of a linear differential equation, right? So the next example, it is example 2. X dy by dx plus y minus x plus xy cot x, which is equals to 0, where again x is not equals to 0. So x is equals to 0 means the first dy by dx term becomes 0 only directly. So it is not in the linear form, right? So for that reason we are taking here x is not equals to 0. It is given in the question itself exactly. So now the solution. Write on the given x dy by dx plus y minus x plus xy into cot x, which is equals to 0. So now which implies x dy by dx. Here from y and x into y cot x, take y common outside, plus of y outside inside, 1 plus of x cot x. This minus x take to the RHS, it becomes plus x, right? Now divide both side by x. Let's see what we get. Divide by x on both sides, right? So it is dy by dx plus of 1 upon x plus x get cancel, cot x into y, which is equals to 1, it is, right? So now the equation is in differential equation of the form. Now it is in the standard form, right? So this equation is in linear differential equation form. So now comparing with dy by dx plus py, which is equals to q, right? So here the value of p is here, where value of p is 1 upon x cot x and value of q is 1 here, right? So now we have to find integrating factor. IF equals to e to the power of integration p dx. The integration value of p is 1 plus x cot x, 1 upon x plus cot x into dx. So the value what we get here in the first term e to the power of log x, 1 by x integration is log x plus cot x integration is log of sin x, right? So now e to the power of log m plus log n, right? Log m plus n can be written as log mn, which is equals to e to the power of log x sin x, finally, which is equals to e to the power of log get cancel, only what we get here x sin x is nothing but our integrating factor, right? So now substitute this the relation, the general solution. So the general solution of given differential equation is given by the relation. Which relation it is? It is y integrating factor is equals to integration of q into integrating factor into dx plus of c, right? Now substitute here integrating factor value. Y as it is, integrating factor is x sin x, which is equals to value of q is 1, again integrating factor x sin x, right? Dx plus of c, right? So now in the LHS, which implies y x sin x keep as it is, which is equals to x sin x dx integration of x sin x dx plus of c. Again it implies y x sin x, which is equals to here integration by parts again, right? First function as it is, integration of second function minus whole integration of differentiation of first function into integration of second function, right? Plus of c. Now the dx is right for whole term. So y x sin x, y into x sin x, which is equals to first function as it is, integration of sin x is minus cos x, minus of integration of x is 1 into again integration of sin x is minus cos x dx plus c as it is, which plus y x sin x, which is equals to minus x cos x minus x cos x. So again what we get here, minus minus plus outside here, minus minus plus integration of cos x is sin x plus of c. So now dividing throughout equation by x sin x, and what we get here, dividing by x sin x, so which is equals to, I'll write here divide by x sin x on both side. So after dividing what we have, what we get, I will write directly here, or if you want to take one more step you can take. So y, which is equals to what we get here? Here x sin x get cancelled in the LHS. Here minus x cos x upon x sin x plus of sin x upon x sin x plus c upon x sin x, right? So now y equals to, what we get? Y equals to here x get cancelled, cos by sin is minus cot x plus sin x get cancelled, 1 by x plus c upon x into sin x, right? So which is nothing but our required solution.